Hello and welcome back to my channel. In this video, I'm going to be reviewing the mole concept. The first question I have says, calculate the number of oxygen atoms in 25 grams of sulfur trioxide. So to solve this, the first thing we do is convert the 25 grams of SO3 to moles. And to do that, you need the molar mass of SO3. So sulfur has a mass of 32.06. And since you have only one sulfur, then that's just going to be the mass, okay? Oxygen has 16 grams approximately as the mass. Now we have 3 oxygen. 16 times 3 is going to give us 48. So the total, so this is times 3, 16 times 3. So the total is going to be 80.06 grams per mole. This is the molar mass of SO3. To convert this to moles, we would need the mole to be on top. So you're going to put 1 mole on top, divide by the 80.06 grams of SO3. These grams will cancel out, and we are left with the moles of SO3. Now, the question is to calculate the number of oxygen atoms. So we're going to convert this to moles of oxygen. How many oxygen atoms do we have in SO3? There are 3 moles of oxygen, okay, in 1 mole of SO3. So in 1 SO3, there are 3 moles of oxygen. So these moles of SO3 will as well cancel out, and we're left with 3 moles of oxygen. Now, to convert the moles of oxygen to atoms, you would need the Avogadro's number. So that would be 6.022 times 10 raised to the power of 23 atoms in 1 mole. So according to Avogadro, 1 mole of a substance is equal to this Avogadro's number. So the mole oxygens will cancel out, and we're left with atoms of oxygen. The final answer would simply be 25 times 3 times 6.022 times 10 raised to the power of 23, and then divide by 80.06. And that gives us a 5.64 times 10 raised to the power of 23 atoms of oxygen. Okay, and that is it. The next one I have says, determine the percent composition of sodium bicarbonate. The first thing we do for this one is find the total mass. So sodium, there are 2 of them, multiplied by the mass of sodium in the periodic table. Carbon, you have just 1, multiplied by the mass of carbon in the periodic table. And then oxygen, we have 3, multiplied by the mass of oxygen in the periodic table. For sodium, we have 22.99 times 2. That gives us 45.98. This will give us exactly the same thing, while this will give us 48. The total mass or the molar mass will be to add them all up. And this is 105.99 as the total mass. So the percent composition is the mass of the element divided by the total mass. So starting with sodium, percent sodium will be equal to 45.98 over 105.99 times 100. And this will give 43.4% approximately. Now, percent carbon will be equal to 12.01 over 105.99 times 100. And this one will be 12.01 divided by 105.99. That gives me 11.3%. And the last one, percent oxygen, would be 48 divided by 105.99 times 100, and this one would be 48 divided by 105.99 times 100, which is 45.3%. So that would be the percent composition of the elements in that compound. And one way to confirm that what you did is correct is to add up all the percentages. They must equal 100. The next question I have says, a compound is analyzed and found to contain the following composition by mass. Carbon has 40% by mass, hydrogen has 6.67% by mass, and the remainder is oxygen. Determine the empirical formula of the compound. So we have our carbon, we have hydrogen, and we have oxygen. We're going to assume 100 grams, okay? Which means this is going to be 40 grams. This would be 6.67 grams, and this would be, now, I need to find the percent of oxygen. What you do is add these two up and subtract from 100. Remember I said percent composition is a total of 100 once you know all the elements involved. So 40 plus 6.67, then subtract that from 100, that gives us 53.33 grams, okay? Now we're going to divide all of this by the individual masses. So that of carbon divided by the mass of carbon in the periodic table, mass of hydrogen in the periodic table, and then mass of oxygen in the periodic table. Now, the division gives us the moles. So 40 divided by 12.01 will give me a 3.33 approximately. 6.67 divided by 1.008, that gives me a 6.62 approximately. And the last one, 53.33 divided by 16, gives me a 3.33 approximately. The next step will be to divide by the smallest mole. This and this are the same, and they happen to be the smallest, so they divide themselves and also others. Okay, like that. Now, that gives us the ratios. So the empirical formula of this compound would be C, 1C, you don't need to put the 1, then H2 and O, and that is it. That's your empirical formula. Next, it says if the molar mass of the compound from the previous question, so the one we just solved, is found to be 180 grams per mole, determine the molecular formula. So from the last question, the empirical formula we found was CH2O. To find the molecular formula, we're going to find the empirical formula mass, the mass of this compound. So carbon is 12.01 times 1, so that's going to give us exactly the same thing. Hydrogen is 1.008 times 2, that's 2.016. And then oxygen is 16 times 1, gives us the same thing. So the mass is just going to be the sum of all these masses. So 12.01 plus 2.016 plus 16 is going to give me 30.026. So this is the mass of the empirical formula, and they gave us the molar mass of the compound. What we're going to do is divide the molar mass that they gave us by the empirical formula mass. So if we do that, it's going to give us approximately 6. So that means that the molecular formula is times 6 of this empirical formula. So this is originally 1C. 1C times 6 is 6 Cs. The 2 hydrogens times 6 will be 12 hydrogens. And then the oxygen, which is 1 times 6, is 6 oxygen. So that would be the molecular formula of that compound. Okay? I hope this was helpful, and I wish you all the best as you write your final exams. Do have a wonderful day, and thank you for watching.